So over here, there is a weight acting downwards, W, right? Now, at this point of time, isn't the normal force equal and opposite? So we can draw the same length, both sides. But when the person is actually going to jump up, he or she is exerting an additional force on the ground. Correct or not? Correct? To jump up, you have to exert an additional force on the ground. That additional force causes the normal force to increase. Do you understand that? By jumping. Yeah. Like, you think about it, if this is a piece of wood that can break or a piece of glass, and it just so happened that if you stand there, you will not sink. You will not crack the glass. How do you break the glass? You can let slowly go down, and then you try to jump up. When you try to jump up, you're actually exerting an additional force on the ground, right? Correct? That additional force causes the normal force to go up. Right? This actually, I'm talking a little bit of Newton's third law already, action-reaction. Correct or not? And it is this force that pushes you up into the air. You have a floor, okay? All right? This object here has a weight, W. Yeah, in order for this guy to accelerate, A equals to 8 ms minus 2, this floor has to exert something that is greater than W. So we can say it's W plus the net force. Okay, the net force. Okay? Okay, look, I'm standing here. What's my weight? That number, right? I jump. Right? Just as I'm jumping, right? I'm now exerting a push on the floor, right? What is that value? Okay, it is this one here, force by the floor, which is what you are calculating. You see, your force exerted on the floor has a normal force. Remember, the normal force is always changing depending on what object you put on the floor. So this force by the floor has to be greater than your weight. Correct or not? If you exert a force on the floor equal to your weight, you will not jump, you will not lift off the ground. Get it? So in order for you to lift off the ground, you have to exert a force on the floor greater than your weight.
So this force by the floor is just like a reaction?
Yes, correct. So the force by the floor is actually your force that is acting on the floor downward.
So that's like Newton's law.
Yes, correct. So when I write down force by the floor, it's actually you exerting the force. But you want to jump up, So when you want to jump up, you accelerate upwards. Actually, yeah, when you accelerate upwards, there is a net force, right? So that net force gives you your acceleration value, which is in this case 8. Do you understand what I mean?